Good morning, students. Today we are going to start practice set number 2.3. But before that, the concept on which the sums are involved in this practice set, we are going to learn about that. You can see here we have the concept of surds. Now, first see this way we have the concepts of surds. What is this? This is called, this red one A is called radicand. Yes, this is called radicand, and this N is called order, and this sign is called, this sign, radical sign. This way we can say this is called a surd. Now, how we can say this is a surd or this is not a surd? On the basis of which concept we are going to decide. So there is few concepts. The first one is that n is a natural number, but n is not is equal to 1. Yes, n is a natural number and n is not is equal to 1. Second one, a is a rational number. A is a rational number. And the third concept what we needed, n order of the radicand A, or we can say A raised 1 upon n is an irrational number. If these three conditions are fulfilling, then only we can say the given surds, whatever we have, the radicands order or the radical signs, that are the surds. Otherwise that is not surds. So, or in our local language, for our understanding, we can say that, for an example, if we have like root 5, here we don't have any order. If there is no any order we are able to see, that means there is a order of 2, that is called quadratic surd. There the order 2 is already mentioned over here, which is not compulsory to show. And here we have the radicand 5. So radicand 5 is a rational number and positive, we can say positive rational number. That could not be negative. Positive rational number, yes. But here what we have, the third conditions, and root A, that means what we have, this is an irrational number, or we can say 5 raised to 1 upon 2 is an irrational number. Yes, this is irrational number, so we can say this is surds. This is surds. If rather than this, if we have here 4, if we have 4, so we can say at the place of 5, 4 come. So we can easily find out the value of this is like 2 into 2 is equal to 2. We got the answer of this like 2. So this is not an irrational number. So we can say this is not surds. Means if we can get the answer according to the order, so we can say that is not a surd. If I am not getting the answer, so that is surd in our understandings language. So this way we are going to identify whether the given are surds and the not surds. Yes. The next concept is like surds. If if surds are in the form of P in the root A and Q in the root A and P and Q are rational number, then these surds are called like surds. Once again, if surds are in the form of P root A and Q root A and P and Q are rational number, then these surds are called like surds. For an example, see over here. Here we have 5 root 2 and 7 root 2. So you just need to see within the root we have the same radicands and the order of the surd will be the same. Here we have the order 2, here also we have the order 2, here we have the radicand 2, here also we have the radicand 2. So we can say these two are the like surds. Now opposite of like surds, that is unlike surds, how you are going to identify unlike surd? Rather than this example, we are going to take 6 under root 5, 7 under root 5, here we have 3 and here we don't have. So can we say whether these two are the like surds or unlike surds? First we are going to check. We have the same radicands, yes, but here nothing is showing, means there is a 2 order and here we have the order 3. So these two are the difference. Here we have the order 2, here we have the order 3. So these are not the like surds. So this is our unlike surds. I think you got it. If we are going to compare, radicands are the same and order are the same, so these are called the like surds. And if order are different, radicands are same, then also that is unlike surd. If order are same, for second example, if order are same but radicands are different, then also this is called unlike surds. So this way we are going to identify the like surds and the unlike surds. The next concept is rationalization of surds. If the product of two surds is a rational number, then each of the two surds is called a rationalizing factor of others. For an example, here we have the root 2 and the second one root 8. Yes. Now as this is product of these two, whenever we are going to do the multiplication of these surds, we got a 2 is 16. Here we don't have order, that means 2, so we can say 4 into 4. Now 4, we got the answer. Yes, the product of surds are rational number, we got that, because 4 is a rational number. 4 is a rational number, therefore we can say root 2 is a rationalizing factor of root 8 and root 8 is a rationalizing factor of root 2. This way we can say if the product of these two surds we got the answer rational number, so we can say the first one is the rationalizing factor of the second one and the second one is the rationalizing factor of first one. Next concept is comparison of surds. Comparison of surds means how you are going to say which one is the greater and which one is the smaller. For example, here we have the root 5 and root 7. Yes, which one is the greater and which one is the smaller? How we are going to decide? So that is, we can going to do the comparison between should be between like, or we can say the surds having same order. Or you can see here we have the 2, root 5, root 7. The order of root 5 is 2 and order of root 7 is 2. So we can say, and whenever the order are equal, so that is we are going to do the comparison according to the radicands. If the radicands are smaller than the second one, so we can say root 5 is smaller than root 7. This way we can going to do the comparison between the surds. The things what we have to keep in our mind, the comparison should be between the surds having the same order. Whenever we are going to do the comparison between these two surds, we have to keep in our mind the order of that surd should be same. For the second example, here we have 5 root 3 and 7 root 5. Here we have the order 3. Can we do the comparison between these two? Can we do? No. As because here the order is 2 and here the order is 3. So here we are not going to do the comparison between these two. So for the comparison we need the surds like with the same order. So we can going to do the comparison according to the radicals. If the same thing we have 5 root 3 7 root 5 this way. So this time we can do the comparison. Now how we are going to do the comparison? This time this 5 went to the inside the root will become 5 into 5 into 3 and here 7 into 7 into 5. So this way we are going to do the comparison. We get the answer. Which one is the greater one is the greater, which is the smaller one is the smaller. The next concept is operations of surds. Operations of surds. Mathematical operations like addition, subtraction, multiplication and division should be done in like surds. If we have the like surds, so we can do all these mathematical operations in that surds. Let's start practice set number 2.3. The first question is state the order of the surds given below. We learn how we are going to identify the orders. In the first one we have order 3. Here nothing is written, that means 2. Here we have 4. Here nothing is there, means 2. Here also we have 3. So how we are going to write the answer? The order of given surds are as follows. Like in the first one we have the order 3. In the second one we have the order 2. In the third one we have the order 4. In the fourth one we have order 2 and in fifth we have order 3. We can write directly or we can write like the first one 3 root 7, the order of given sort is 3. Both the way we can write the answer. If you are writing including all these 5 only once, we can write this way. If you are writing separately, so for each and every sums we can mention this way. The order of the given sort is whatever is the order we have in the questions. Yes. Now turn to the next sum. Sum number 2. State which of the following are surds given below. Now here we are going to do the identifications of these surds, which are surds and which are not surds. So here in the first one, order 3 is a natural number and n is not is equal to 1. Yes, we have the order 3 and that is not is equal to 1. The first condition is fulfilled. Now the second one, 51 is a irrational number. Therefore 3 root 51 is a surd. Yes, we can say. Now second sum, order 4 under root 16, first one. Order 4 is a natural number. Yes, and n is not is equal to 1 also. So the second one, 16, 4 root 16, or we can say this could be like that, 2 into 2 into 2 into 2 we can write. Order is 4, 2 2 is 4, 4 2 is 8, 8 2 is 16. So there is the order of 4, 1 2 3 4, we can make the pair of 4. It will comes out 2. Therefore 4 root 16, or we can say 16 raised to 1 upon 4 is not an irrational number. Therefore 4 root 16 is not a surd. Yes, this way we can going to identify, we can going to state with the reason given are the surds or not. Now turn to the next sum. Sum number 3. Classify the given pairs of surds into like surds and unlike surds. Yes, just recall what is the like surds. Whenever we are talking about the like surds, the order should be same and the radicands, on the basis of that we can say radicands also same, so we can say that is the like surds. The first one, 52 and 5 root 13. So here we have the order 2 and here also 2. One condition is fulfilled. But here we have the radicand 52, here we have the radicand 13. Can we factorize this 52? Yes, we can write this like 52 is equal to 2 2s are 4 into 13. Yes, root is order is 2, make the pair of 2, we can say 2 comes out and here we have the 2 root 13. So at the place of root 2, order 2 root 52 we can say 2 root 13. Now you can do the comparison between these. Here we have the same radicand also. Therefore root 52 and 5 root 13 are like surds. These are to the like surds. Now the second sum, what we have? 68, 5 within the root 3. The same way here also we have the order 2 and here also we have the order 2. Orders are same, 9. Now we have to compare the radicands. Order 2, 68 is equal to, factorize it. 68, do the factorization. How we are going to do the factorization? 2 3 is 6, 2 4 is 8, 2 1 is 2, 2 7 is 14, 17 1 is 17. So we can write 2 into 2 into 17. The order is to take the pair of 2 out. So 2 within the root we have 17. Can you say the radicand of the first one is 3 and the radicand of the second one is 17? So these two are not the same. So therefore root 68 and 5 root 3 are not like, or we can say are unlike surds. So first we are going to check the order, then radicands. If both are same, so like if we get any difference between these two, so we can say that is unlike surds. Now sum number 4. Simplify the following surds. Simplifying the following surds. The first one of that 4. Here we have the 3 sub questions. Now how we are going to do the simplification? The first one 27. Simplify, that means what we have to do, just do the factorization of this 27. We learned that how we are going to do the factorization. 27 3. So 3 9s are 27, 3 3s are 9, 3 1s are 3. So we can say 3 into 3 into 3. So it could be like 3 into 3 into 3. This way. Now as we learn over here nothing is mentioned, that means order is 2. So we have to make the pair of 2. So it will come like 3 come out and within the root we have 3. This will remain. So 3 root 3 is the simplest form of the first one. Now we have the second one, root 50. So factorize this 50. 2 2s are 4, 2 5s are 10, 5 5s are 25, 5 1s are 5. So we can say 2 into 5 into 5. Again order is not mentioned, that means 2. So we have to make the pair of 2. We got the pair of 5. So it will become like 5 come out and within the root we have 2. This way the simplest form of the root 50 is 5 root 2. Now the third one, root 250. Do the factorization. 250 starting from the 2. 2 1s are 2, 2 2s are 4, 2 5s are 10. 5 2s are 10, 5 5s are 25. 5 5s are 25. 5 1s are 5. So we can write it 2 into 5 into 5 into 5. So as in the earlier sums we got order is 2, so make the pair of 2. So it will come like 5 come out and 2 into 5 remains. It converts like within the root 10. So it is the simplest form of the root 250. So this way if we have the any of the surds, we can go to simplify that into the lowest form of that surds. Now as you seen our this video, we solve few sums of the each and every questions, but in the textbook we have a lot of the sums, so that all sums are homework for you. Remaining sums of practice set 2.3, what we did today: question number 1, question number 2, question number 3 and question number 4 you have to solve for your homework, and the remaining sums question number 5 onwards we have to solve in the next video. Thank you.